right, this is number 9 from Unit 2 on the midterm review. So the following functions are 1-to-1, all right, which means that the function has to pass the vertical line test, for starters, to be a function, and then it would also pass the horizontal line test, which means that an inverse exists. So for these, we want to find the inverse and graph to confirm. So take a look at number 9. When you find the inverse, the first thing you want to do is reverse the x and y coordinates, or variables, rather. So we'd start with this. And then our goal is to solve for the new y value. So in order to do that, we first need to get rid of this denominator. So we're going to multiply both sides by y minus 3. Distribute on the left. So we have xy minus 3x. It's going to equal 5 on the other side. We're trying to get y by itself, so we're going to add this 3x over. So we have xy is equal to 5 plus 3x. And then last but not least, divide both sides by x. So there's a couple different ways you could write your answer. So we have how it looks right now. Or you could split this up into 2 separate fractions. So 5 over x plus 3x over x, at which point the x's on the second term would cancel out. So you could just say 5 over x plus 3. Either one would be your inverse. And remember, the notation for inverse is this. Okay, so for 10, we need to do domain and range. So you should be able to tell this by looking at the equation. And the thing about inverses is whenever you find the domain of your original, because when you take the inverse, x and y switch, and domain and range represent x and y, those are going to switch as well. So whatever the domain or your x values are of your original will be your range of your inverse. So if you look back at the original, the one thing that x cannot be would be positive 3. So we can say all reals, but x cannot equal 3. Same thing for your range, but y would not be able to equal 3. Can't really tell the range of your original without graphing it. However, we can tell the domain of the inverse by looking at the equation. So if we look down here at either one of these, since x is in the denominator, the one thing that your domain could not equal would be 0. So that will be your domain of your inverse, which means your range of your original would be everything except for y not equal to 0. So the part about confirming your answer by graphing is, it's optional, but it's never a bad idea to do this. Go to y equals, graph your original function, which would be 5 over x minus 3. Graph your inverse, whichever way you chose to write it. But then in a third equation, or third one, put the line y equals x. And what's going to happen is there's your original, there's your inverse, and then there's the line y equals x. So it was kind of like a mess, but the original and the inverse, they technically reflect over the line y equals x, which might not be super easy to tell on this one, but what it is easy to tell on this is that since the original and the inverse intersect one another, notice how the line y equals x is also intersecting them. So a way you can check to make sure you did this right is if your original and your inverse overlap, the line y equals x should also interlap. So all 3 of them at the same time should overlap. And the same thing happens here. So that should be a visual check to make sure that you did the inverse right. All right, let's take a look at the second one in this section. So we're still finding inverse. It's a little bit of a different function. This is just it's a square root or a squared function. So switch out x and y. So x is going to equal y plus 3 squared over 5 plus 4. If we solve for y, first we're going to do is subtract 4. So x minus 4 will equal this fraction. Then you're going to go ahead and multiply both sides by 5. Now be careful over here that you distribute the 5, or I suppose you could leave it out front. And over here the 5's will cancel, leaving us with y plus 3, the quantity squared. We're going to need to square root both sides. So we're left with the square root of 5x minus 20 is equal to square root will cancel out the squared, so left with y plus 3. And then all we have to do is subtract 3. Now be careful, make sure that does not go underneath the radical. All right, and since this is our inverse, technically, we can rewrite this as, so we call this function f, so f inverse of x. And now domain and range. So domain of your original, this is an x squared function. There's not going to be any restrictions on your domain, so that would be all reals. Although we probably should say x has to be greater than or equal to 0. There are going to be some restrictions on this because this function is not one-to-one, actually, now that I think about it. Great thing to realize as you're making a video. It's fine. All right, so let's see here. X plus 3, quantity squared, over 5 plus 4. All right, so let's take a look at that graph. Okay. All right, and then let's take a look at the graph for our inverse. This should tell us a lot. So second square root 5x minus 20 minus 3. Alrighty. Alright, so as you can see from our the square root function, the inverse, the range is only going down to -3. So we're going to have to restrict our original domain to be everything from x greater than or equal to -3. Alright, which means our range of our inverse is going to be everything greater than or equal to -3 down here as well. Alright, and if you double check that point on the red graph, it's starting at 4, I believe. Yep. Alright, so at 4, -3, that's where that graph is starting. So I'll show you here. 4, -3 is right here. So your range is everything from -3 and above, and your domain is going to be everything from 4 and above, which will also be your range for the other one. All right. So again, number 11 is not one-to-one. And it's because it does not pass the horizontal line test. But if we restrict that graph to only say everything from -3, so basically if we ignore this left side of the graph, that function will be one-to-one. Which brings us to our next question, which is what properties does the relation have to have in order for an inverse to exist? It has to be one-to-one. All right, which means it has to pass the vertical and the horizontal line test. All right, so if you had a graph that looked like this, for example, if you take it and move a vertical line, oops, if you move a vertical line through it, it passes the vertical line test. And if you take it and rotate it, it'll also pass the horizontal line test. So this graph would have an inverse that exists. However, we had a similar function, but if it had more terms to it, this would pass the vertical line test. So it is a function. All right. However, it would fail the horizontal line test. So no inverse would exist for number 13.